Today, I am talking about functions in R programming. How do we apply functions and how do we build our own functions? Right, stay tuned and watch. Thanks for being around. My name is Bigba Bright, and it's always a pleasure. Yeah, so we have inbuilt functions in R, and we also have functions that we can actually develop them by ourselves to work like the way we want it to work. In R, when we talk about a function, we are simply talking about a set of rules or a particular rule that you have put them in a form of in a manner that they interact in the way that you want it to be. For instance, I create variables, I create objects, and the way I want the objects to interact and then give me a result is what we call a function. So we have inbuilt functions, and I'm going to run through that quickly. And so I'm just creating some two, I'm just creating some few vectors here. And so I've created this vectors I have here, and I'm going to use that one to look at the inbuilt functions. So I have a vector of integers, I have a vectors of numbers, and of course, I have a vector of characters. So we're going to look at how to be able to apply the inbuilt functions. The inbuilt functions, I'm unable to put all of them together, but those that look like the ordinary words we have, like any. In R, we use any is a function. The word any is a function. For instance, I'm just looking for any of the value, or yeah, something like that. And so it can just pick any value from a vector, and then you are good to go. So if I have something like this, any, any is a function. And so let me say I have any of this and then print it. No, the object did not work. So I can just say any of. So I'm going to pick this particular vector and I'll say any of the values within this vector, compare it to what I have here. So you can actually just say any of the value. For instance, so this is what I wanted to do in the first place. So I have n here and so I'm just going to pick the vector which is called n1, and then I can just say plus 2. So it will just pick any value at all and then decide to add 2 to it. And then when you run that, well, I was trying to coerce it. Yeah. Then, but mostly, the most effective way to use any is when you are doing relational kind of relationship. You want to find out whether something is greater than this or that. So if I use the word like greater, that way it's like a comparison. So it's going to return a boolean which is true, and then that is what is going to happen there. So here I could actually say check in this particular vector and see whether any of the value is greater than 20, and it will say yes, there's actually a value which is greater than 20. It's not going to show you that value, but it's like a way of asking a question, and then it will check into the database and say that yeah, there's a value like that. So that's what we use any for. I don't know if I can also use it to check for characters. I'm sure, for instance, if what is it? So let me try and check it with the characters. I haven't used it with characters before, but let me try with one character and then we see. So we have any here, and then I'm simply going to say that I have a character. What is it? Like Y here, and then I want to find out whether there is a match with my name, which is there. I'm supposed to put it in double quotes, and then run it and say, I will say it's true. So it's a way of asking a question whether this thing exists or not, and then it will return. When it returns true, it means that it exists. And so it's the same thing here. You can check any, and then it will just pick. It will just find out whether there is any value like that. Now we also have all. All here means you are trying to compare what the vector here to the rest of the figures, and then that's what I am doing here. I can just say all. All means it's going to pick all the object in this particular vector and compare it to this. So it will say false. False means that we do not have all the numbers or all the elements of the vector being greater than 50. So what it tells you is that there are some that are greater than 50, There are some that are not greater than 50. For this condition to be met, you have to make sure that everything there is greater than 50. So if you come here, also run, you are likely to get false. And that is always like that. Now, these ones, like the mean, is simply to just give you the mean of the vector. You can look at the summary. It gives you the 5-point summary. Then first, then these are all you can check for the median. You can check for absolute. Absolute means print without the sign attached to it, whether it is a negative number. Yeah, so you print only the absolute. So it will print. See, even here we are talking about negative 55. I have to print 55 for you. We use square root to be able to get a square root of a number. Then truncate. Truncate, what is happening is if you have numbers, if you have vectors that has decimals, like 2 point something, as you can see, I have this particular vector here that has decimals. So if I run it, that vector is called, what the variable name is NN. And so what we use truncate to do is to simply make sure that we take out all the decimals and print them as integers. So when you use truncate, that's what the function does. So we're just going to truncate it. So it will print only the integers, leaving the decimals. Now, we know all this cos, the tan, and then the sine, all of them. So you find the cos function of this. You can find the tan. You can find log 2. You can find the ordinary log 10. This is exponent, and then this is substring. I think if you can follow my videos, you can check strings. We've looked at substrings to be able to substring and then isolate a certain part of a string, and then you are good to go. Now, there's also one important function, inbuilt function in R called grep. Grep is actually found in almost all the programming language. So what we do is, this is the function called grep. And let me say this, if you have any function that you don't know how it's being used, just simply come and put a question mark like this, and then I'm just going to say grep. Then when you run it, it's actually going to produce all the information you need about grep on your on this particular console. I'm going to roll this one up, and then you will notice that everything you need to know about grep will be here. The example of how to use it, everything is here, and then you can just have a look at it. So that's how we check for the usage. Now, if I come here, look at, I've just built, these are strings, different strings that are packaged into something that a vector called st1. Then I create a pattern. Then this is the pattern that I've created, and I've given that that particular pattern to a variable called pattern. So I can now say grep. The grep means I'll now use this particular pattern and find out whether this pattern is found in this vector, and that is it. It will simply print out here. It is found there. It's actually found in from 1 to 3. It's going to print the index. It tells you that the index position 1, 2 to 3 is where you can find A, B, C, and then that is it. And then you have it over there. So I can simply just continue with this. What is it? I can say maybe I have this particular variable here. So I want to run this. Okay, I think. Okay, yeah, that runs properly. And so if I come, I want to grep car. So I want to find out whether car is found in any of this. So you simply just indicate the pattern that you want, and then where it is, then I'm just going to run that. So it will say that it will print the index position for you, and then you can see where car is. Car is actually found in the next index. As you can see here, it will find in the second index. So here, every word or every string in R programming, we don't call it words, we call them strings. They are in double quotes. So every string here is counted as 1. So the second one is actually what we print. So it will give you the index that, yeah, we found it in the second particular word or string, which is found in the double quotes. And then the same way, we can check for bike, and then we see that it's found in the 3. We can grep, and then we ignore uppercase. So when you do that, is going to ignore the case sensitivity, and then we set that to false. So in that case, we can find bike, and then this is also bike. Yeah. So These are to retain the vector indices of both matching elements. Like I can say great bike inside X and then ignore case sensitive, which is true. Then it will print the two of them, which is this one and then that one. But if you say ignore case sensitive, ignore dot case, and we set it to false, it means we should consider the case sensitivity, and that is it. So here I can also use the same thing, and then we say the value is. So here, when you turn the value is equal to true, it's not going to print the indexes. It will rather print the value. So here, for instance, this particular place, if I had set here, if I have said that value, and the value, if I had set the value to true, and I decide to print it, it will rather print the actual, strings, but not the index positions. If you don't set value to true, it will print the index positions without printing the actual word. And that's the difference here. So to understand grep is used to isolate a string. Yeah, it can be any string at all. You can have maybe one part of your word or your name. You can just isolate a certain part of it, and then you are good to go. Now we have what we call a substitute. It's also a function. And then if you run this line 2241, we are simply going to look at how this function works, like I've already explained. So I have England is beautiful, but not part of. I think I should add something here. Not the part of EU, or so I think I didn't write this one well, but not part of EU. So that's the string there. So I'm just going to run that. So I want to substitute England with UK found in this particular vector, and that's it. It's that simple. So if I run substitute, so you will see England is beautiful, but not part of EU. You rather see UK. Look at the answer in the console here. UK is, so I've substituted England with UK, and that's what the substitute is being used for. We use substitute a lot when we are cleaning data. If you are learning how to clean data for the first time, then you may want to use substitute, to be able to make sure that you take all those things out. This is not applied only in strings. It can also apply in even in ordinary vectors. We can do that. Now, structure split, which we always say the stir split, is you also use it to be able to make sure that you split words, like the words that you join together. For instance, I have a string here, split all the characters. Then I want to assign it to A. I've done that. So if I move from there, I want to say, if I use the function struct split, I'm going to split the whole of this string on top here. But how do I, all the string has been packed into this variable called A. So I'll simply say struct split, bring the variable name. And then if I come here, if I leave it at this particular point where I don't have the double quote, there's no space between it. It will split each of them. It will split them letter by letter. Maybe I should run it and let's see. I think I've already run that. So let me clear the console a little bit. And then, so I'm now going to split the vector. You see, it will split everything into, including the spaces between them. Arrow will consider all of them as characters and split all of them into, a letter by letter. It's one of the ways that you are able to split everything. Now, apart from that, let me go a little further, then it will help us understand. So here, I'm saying that R is the statistical analysis language, all right? So we can split it, and then, so we pack that into it. And then when I'm going to split it, I'm going to say, okay, I've packed it into a variable called GF. So the variable, you split the variable, and what's the split formula? So I'll come and say split is equal to, when you leave this space, it means you are splitting words. So it will split each of them as a word instead of all of them as as letters. So that's the difference. So you see that R is and to split it with all the spaces as characters, and that's what it means. So to split them just the way we have done. And so it's not only the space we have kept here that can be splitted, we can also split it using signs. There are some people who type can use a forward slash or percentage to differentiate the words. Yeah, there are some countries who type like that. I was actually surprised to see it somewhere, but it does. Instead of we leaving space, it's not everybody who type and leave space. Some use forward slash, some use percentage, some use different symbols to separate words. So when you have that, you want to split the words, you simply just specify. Here, it was spaces that we wanted to split the words by. So one word will be different from the other through a space. Here, one word will be different from the other word by what is it? Percentage. So we are splitting using the percentage. So we simply pack the string into this variable, and we now say structure split the variable, then the split. What are we splitting? We are splitting at the percentage. So wherever I see the percentage, it takes it's separated from the other word, and then that's what is going to happen. So it will simply now leave these percentages out. It's the same way we have here. We can split it using this particular index 0 to 9, and then 0 to 9, and then outside plus. That's how we want to split it. So it's going to check 0 to 9, and then plus, and that's all. It's going to split that for us. So let's see how that's going to work, and then split it. So it will split it. So check here all I. So you notice that it has splitted 6 out, take 5 out, 6 is out, and then in that order. I don't have time to be able to explain all of them, but it's one of the ways to be able to separate words. So now these are other inbuilt functions like to lower. It simply means that you are to, if you have typed something in lower uppercase, you want to bring it to lowercase, then you can do this. Then this is to upper. And then remember, well, anytime you want to do things like this, you can actually select. Maybe you are not interested in everything, so I can just put like this, and then maybe I want to put, let me say 1, and then let me try and see. So it's going to just print only the first word, that's my name, and then it will change it into what uppercase, and that's all. So we can always, there are also other inbuilt functions like, what is it, do if. It's like run if. You see, we use it to be able to create random numbers. There's one here. So you can also check standard deviation. So you've already created this vector. So I can check for standard deviation. Yeah, so it will give you the standard deviation of the vector. And then we can check the variance. What the difference between variance and standard deviation is almost. And so you have, that's the variance. But you can do a variance kind of like variant test. So in that case, you must have your y, your y part, and then your x part, and then you're just trying to test it. When I'm doing hypothesis in R, I'll explain this better. But when you do your variant or test, it's actually like F statistics, and then that's going to give you your results here. You can see your confidence interval, you can see your p-value, which is 0.99, which is actually not significant. And then you can check your variance around here, your ratio of variance, which is here. I will do, watch out for my video in hypothesis testing in R, and then I'll explain that quite well. So you can check quantiles, like when you want to group your data into quantiles. Yeah, so I have this data here, and I want to group it into quantiles with the probability of 0.1. So that's 10%. So, and that's how it groups it for me. That's 10% probability. And then range. What is it? We use range to be able to, so if I have a vector of so many numbers, I want to know the lowest and then the highest. You just use range. It will just print the lowest and the highest. So this is the lowest 12, the highest is here, and then that's all. We can reorder the vector, and then let's see. Reorder is not working. I needed to add another variable. So here, we use this particular function called scale to be able to centralize metrics. If you have metrics, you want to centralize it, then, so I'm building a small matrix here. I'm just going to run that. And so I'll just say scale. So the matrix is back to A. So let me just say A matrix. So it will simply print the centralized portion of it, and that is it. This one. So these are inbuilt functions. There are a lot of them, but these are the most use ones that I just decided to give. Now, let's go a little bit and look at functions. The function that we have just run through right now, all of us can also build the same function and let it work the way we want. So let's assume that, what is it? Somebody consult me and say, I have a plot of land measuring 70 by 70, and I want to put a restaurant over there. So I intend to have this number of tables inside that restaurant. And then this is the surface area of each table. So how many tables do you think anticipate that I'll be able to, it to fit in that particular? It's left up to you. You write a function, and you can write a function and simply do this calculation, which is very simple. Right. So in function writing, the most important is the function name, followed by the function argument, and then followed by the function body. The function name is like the variable we have created, like I have here, followed by the word function. When you write the word function, it will change. And then the function will take an argument. So the entries here are the argument 1, argument 2, all the way. You can have as many arguments as you want. If you open this curly bracket and close it, within the curly bracket is how you want the argument, which are like variables, to interact. Which way do you want them to interact? Then you create the interaction. That's the function body. And then you now return the function, and that's all. So each time you call in the function will ask for those argument 1, argument 2, and then when you provide those arguments, then it will then use the way you allowed it to interact in the function body, and then give you your answer just like the way you want. Now, I hope this explanation is clear. Now we come here and we are looking at area of a rectangle. That's our function name. And so we go ahead and say function, we use the word function, and then we're giving it a variable, argument like L and then B. We open up and say, how do we want the argument to interact? We are saying that we are multiplying L and then B. And then when we multiply it, we take it to a variable called area and then return area. This is the difference between function and then, let's say, something like loops and then statement. In statement, you print. In function, you return. You are returning it. Okay? And so anytime you now run, what is the function? So here, I can now come here and then run the whole function, and that is it. So once it runs properly, to call the function is you simply come here and write the function name. It will simply ask you, just like the way if I say, if I also write any function, it will ask me of what I'm supposed to put inside. So now my function name is area of a rectangle, which is here. You see that on top of it, it will simply ask me of the argument A and argument. It will let me do it again, and then can you see on top here? You see it's asking me of L and then B. So I have to provide the value for L. So let's say L is 7, and then B is what, 8. Then when you run that, it will simply calculate the area of a rectangle for you, which is 56. This is the easiest. Now, let's check. We want to write a function to calculate the BMI, body mass index. We know in our minds that body mass, to calculate somebody's BMI, is actually the weight over height square. So what do? We have our function name, which is called BMI calculate. So we create a function and say weight and then height here. We come down and then inside the function body, we say, how do we want it to interact? We are saying that BMI is actually calculated as W divided by height square. So this is H and then square. If you follow my previous video on my Facebook page, What a Big Bad Bright, I've actually indicated some of these what the symbols and how they are being applied in I've done that. You can check for that video. So this is how the function body want to interact, and we pack the interaction into this variable called BM. So we come and return the BM. So now I can simply run all of them like this. And so when I do that, I can now call it. I can call the BMI. So if I say BMI underscore calculate, BMI calculator, it will simply ask me of the weight of the person and the height. So let's say the person is, 68 kilogram, and the height is, so the height, you also would have known the kind of height you are dealing with. Maybe you are dealing with meters. So the person may be like 2 meters. So it will simply calculate and give you, the person will have a BMI of 17. And so you can now check it with your BMI scale, whether the person is. So in each time you now want, you can just, so you see that I can calculate the BMI just like, okay, no, this one is not correct. I use it for, okay. So you can always call the function, and that's what we often see. Go there, and then people open a small box, type A, B, C, D, and then the result is out. So let's look at what is the arrival time. So somebody is, you are working with what is a bus, maybe you're a transport company, and so you want to write a function to be able to determine the time that when a car leaves at a particular spot, the time it will arrive at the next spot. So what do? I say arrival. So this is like Bolga Kumasi. So I say a function, then I have g, which is the distance, and then sorry, g, which is maybe a different variable, and then I have distance, which is here. And then I'm going to calculate. So the speed will be equal to the distance traveled divided by, let's say, 100. And then arrival will be equals to the speed plus, okay, d is departure. So I have the departure time and then the distance. So first of all, I need to calculate the speed, and the speed is simply equal to the distance divided by what is 100. And so we look at the arrival time. The arrival time is equal to the speed plus the distance. So we've asked, this is how the all of them are going to. And so after you have finished interacting, then you come and return the last variable here. You don't return this because I've already used this one here. I've already used the speed inside this particular interaction again. So I cannot return S. I have to return arrival. And then I return my arrival. When I do that, I run it. It's very simple. So the next time somebody now want to travel from Kumasi to Bolga, I simply call the function. So I have the function like this. I think array underscore. So it will ask me of the departure time and then the distance. So let's say the person is departing at 4 p.m. and then the distance from Kumasi to Bolga is around, let's say, 700 kilometers. So I say 700. So that is all. So it will tell me that the person will arrive there at 11. And that's it. You can see it's here. So it will simply calculate and tell you the arrival time. But we know we have not made provisions for other. This is like in advanced countries where they don't have traffic, buses have everything within them, and then they don't have any stop anywhere. So you can estimate how far they are going to travel. In Ghana, it might not be too straight because of traffic and then a lot of interferences, unless you account for those covariants. Now, let's write a function to calculate the surface area of your plates. You have your plate in your house, right? So this is, we are driving ourselves somewhere. So I can actually create a vector of the different plates that we have. So I created this particular vector. I have a plate, I have 3, 5, 1.8. I pack everything into a variable called plate. And so create a function name, which is surface area, and I'll say the function is equal to R. We come here and say, we now look at how the function is going to, and we know that the R is the radius. And a plate has a circular, so it's like calculating the area of a circle. It's practically the same. So we know it's pi, so the pi is actually 3.142 times R squared. Like we always say pi R squared. So times the R, which is here, and then raised to the power 2, the same thing as R squared. Then we retain A, and that's all. So if I have all of that, I can simply run that, and then my function is created. The next thing is, what do I do? Anytime I call the function surface underscore area, and then surface. So if you now call the function surface underscore area, I can just put any value there. I can put, if I can just put, so it means that that plate has a radius of 5. So obviously to calculate the surface area of the plate surface area will be 78.55 centimeters square, and that's it. So what about if I want to calculate the surface area for more than one? It's the same thing that we always use the vector. So I have my surface area like this, and then you just create your C and bring all the. So I have a plate of size one, radius of 1. There's another one, let's say of radius 6, of 3, of 4, of 1.5, 2.4. Then in that order, it will calculate all the surface areas for you one after the other, and that is it. So you can see all of them here. So you put the function at once, and the function is able to generate all the surface area for you, and that is it. It's not too difficult. Pick it one after the other. Pause the video, look at the code, try to write it yourself, and then that's how it is going to state. So we come here. Let's say now this is the restaurant thing. So I have a function LMB, and so I have area is equal to L times B, and then I can say that what a number of tables is equal to area divided by 4, and that's all. So if I have a plot of land, and then the plot of land is, let's say, is 21 by 16. So I can calculate the number of tables that that particular restaurant will occupy. So if it should tell me that that restaurant can take up to 84 tables. Yeah. And that's how it is. We just create the variables and then we look at how. So the BMI calculation, I've already done that. The area of a circle, we should now know that by now. So what is it? So let's look at functions with loops. Yeah, you want to write a function that with a loop. You see, like the 4 loops that I did yesterday. So I have the plate size. It's the same thing like what we have just done right now. So we have a function and we call it V. So we are saying that for I in 1:V, I've not created V. Maybe I should create V here. I'm just going to say V. Okay, no, I think I don't have to create V. I can just leave it. So I'm saying that for I in 1:V. So what are we saying? We are saying 3 point this time is V, and that's all. Sorry, times I, times this particular item, and that's all. So we print what, or we return whatever we have here. So it's actually supposed to be returned. Yeah, I think it should be returned. So we return this. Then I'm going to come here and then run all of them. Yep. So now the plate size, if I now have 4, it will simply come and then print 14 for me. I think I should have run it up to this point here, and then like this. So if I come here and I say plate underscore 4, I'm expecting that it should print more than one listen for me. Oh, okay. Okay, oh, there's a little problem here. So let me, okay. So now I can now run it again and let's see. Return this. Yeah, I've not run everything. That is why it keeps giving me this. So you just press C. I'm supposed to run the entire this. So that works just well. So if I come here and then I want to now print the plate, it should be able to give me this. But that's not what I wanted. I actually want to look at different plates. And so, okay, let me use the word print. And let's see what is going to happen. And so come and then print here. Yeah, this is what I wanted. So in that case, what we are simply saying is that we have given this value. This is the argument, which is V. So now we've given V 4. So it means 1:2. We are saying that 1:2 V. So if V is 4, it will be 1, 2, 3, up to 4. So here, immediately we call the function, it will ask for V. So if I say calculate size. It simply asks for V, as you can see. So if I put there 10, so it means that we are saying for I is the item in 1 is to V. It means from 1 up to whichever value that we give it to. So 1 to 10 in this case. We should come and then say 3.142 times I, which is the I here. So the I here represents 1, 2, 3. So it will pick 1, do the calculation, pick 2, do the calculation in that order. So when I do that, it's going to simply do that. If we wanted to calculate the surface area of them, we would have just simple. We would have said here, this would have been our radius, and we simply just square it, and then that will give us the surface area of all the distance. So here we come, the same function here, and then this place, we are saying that we are creating a function of giving this argument, argument 1 and 2, L and B. We are saying that L times B will pack it into AA, and we are saying that for size in 2 is to 6, print A divided by. So what we are simply doing here is that we are creating a function of length and breadth. And how do we want the length and breadth to interact? We are saying that it is length times breadth, and we pack that into this variable. And so now we are now using for loop. So we are saying that for size in 2 is to 6. So we have 2, 3, 4, 5, 6. What do? We open another bracket again, another curly bracket again, and ask of what is supposed to be done there. So, and that's another, so it's going to print the area divided by the size, which is here. So it will pick the area that we have here. So it will always calculate the areas. So here, it will ask us of the area, L and B. So when we provide L and B, it will now come and calculate the area, come here and pick 2, divide by 1, and then in that order until it's finished. So when we run this kind of function, finished, then we can simply come and then, so now our L is 21 and then 15. So L by 15, then see, it's going to print different areas for us. And that's what we have done. So let's say that if we're having a plot of size, let's say 15 meters by 21 meters by 15 meters, and we want to put different tables of different radius. So what we normally do, we have to calculate the area first, and then we now come and then divide the area one after the other by the individual sizes that we have here, and then we are good to go. And then that's what we have done there. So we can actually combine functions with loops, like with for loop. Yesterday I didn't talk about while loop. So here, the same thing here, you're giving it, and you say for I in, the I is just like for this in this, then you print it out. For instance, if I just write here for I in, let's say 1 is to, let's say 10, I'm simply saying that if I run this, I'm simply saying that for I, the I represents any value here from the first to the last one for I in this and this and this and this. But usually when you use for, it has to be in, you have to close it up. So I have to close this one up here. That's why you are seeing there. Yeah, that is all. So if you have this, if you run it, what is it? I just gave a condition. There's no anything there. So that's why it is, you just see it run, and then nothing is happening. Wanted to explain what that means in any case. So I delete it. So if I come here, you can see the plus here tells me that the function I've just run is incomplete. That's why it changed to plus. So it's waiting for the second part to be run. And so if the second part is not there, come and press escape, and then it will terminate the function. And that's what happens here. So here we have given a function with one argument, A. And we are saying that for I in 4 is to A. So we should print what? B, and say that I is what is a square. And then, so it's just going to return some values for us. And then that is it. So now, anytime we now want, we call the function, it will ask for A. And then when we put the A as 10, then it will print the values from A all the way up to this. So like distances, function. So these are the various functions that we have. You can look at it, you can always write your function the way you want. Here, what we have done is we just have one argument, but I want to use that particular argument to print a data frame. Okay, so here we are saying that distances, and the function is we give it an argument d, and we're saying that for k in 2 is to whatever distance that we want. So when we call the function, it will ask for d. When we say d is let's say 100, so it will start from 2 all the way to 100, and then that is all. And so we come here and say, okay, kk, that's a variable we have created, and we are saying that we should now look at how this function, how we want the variable to interact. Okay, print the first one, print k, so nothing will happen to it, that's the values. So it will start printing from 2 all the way up to d. Then the second part, print k divided by 1.6. And the third one, print k multiplied by 100. And then print kk, and then you round it up so that you have only integers. And that's all. Well, if I do that, I will come and then run it, and that's all. The function ran properly. So if I now say distance, it will ask for d, and that's what is happening. So if you call the function, that's what we mean by call function. If I say distance, the function, you can see the function name, it will ask for d. You can see d in bracket. So what am I? If I say d is 20, then it will print the data frame for me of 20 rows, as you can see. So that's how it is. So it's really very interesting when you are writing. And then within the function body, you can actually allow different interactions to be there. For if you, let's say, here, this particular place, okay, so I'm just going to copy this and paste it again, and then, oh, but I don't have time. There's another function here. So we are also printing the data frame, and then it's the same thing. So it will print a data frame for us. If you want to print a data frame, when you come here, you have to use C. Then tell and go inside the C, explain how you want the interaction to be. So here, we want to print the first one as I. When we print the second one, I to the I square, and then I times 3.2, then in that area. This way, it allows you to be able to do all sorts of calculations in a data frame, and then all your results will be there. So you just need one value. For instance, it can be one value, but you want to convert it into pounds. And then also calculate the BMI of the person. Also look at the person with the highest weight, and then in that order. You can give all sorts of things around here, and then you are good to go. And then that is what we have done here. So sometimes we can create function without an argument. So that's what we have here. So I have a function called population, no argument. So for p in 2 is to 12, then we just print p to the power of 3, and that's all. So if I do that, it will always ask for, so if I bring the, if I call the function, so if I say the function here, if I call the function, which is here, then it will have an empty argument. And then I can put anything inside there. And then I'm good to go. So let me put this, try running it and see what it, oh, sorry. And then it should be able to print out all that I have here. This kind of function is what you see in R. In R, for instance, if I say data like this, that's how it was written. So at this particular point, if I run it, it's going to print all the data that we have in R. We have all the data. What is the data, inbuilt data that is there in R? It's the same thing that we are also trying to build on top here. So I have a function and I'm saying that no argument. So I come to the function body and I use for loop to say that for p in 2 is to 12. So print p to the power of, and that's all. So anytime I call in the function, it will simply print this for us. So here, you don't provide the argument is already seated. So all that you need is the function, and that's all. Yeah. So that's sometimes the problem with this kind of function is that you have limited control over whatever that can happen. So all you need is call the function, and you can't change anything there. Just like if I write data and I put like this, it's going to print the data that has been inbuilt. You can't add or reduce anything. It's already set. So that's what function without argument does. It does not allow you to manipulate anything. It just print. It tells you whatever that has been inbuilt and is seated there. This function is good if you want to build a database of a company in which somebody cannot fix in a different one, cannot reduce anything, then it is set. So this is another function without an argument. And so you have already outlined how you want the function to behave. So no one can change anything there. So it's anytime you want, you just print it and then it will simply print the argument out. So this is another one, and then we are good to go. And so here, look at what we have done. We have function without argument, but we are saying that for a score in, so we are using this random function to create a random numbers, that's 15 with a lowest of 3 and then highest of 30. And then we simply say print, and then we have our score. So we are using this particular score and we are dividing each of them by 2, and that's all. So because it is a function without an argument, all we need is just run the function anytime we want. So this is like when you have packed your results already. So anytime we want, we just call the function and then it will print whatever information we have inside. You can't change anything. That's function without an argument. And so here, I think we've already explained this. So function that generate more output than argument. So I have A, B, and then in that order. So I have the function name, the function itself, and then I have these two argument A and B. I come to the function body and say print A to the power square, print A, print B. And then the next time when I come, I just call in the function and it will do all that I want it to do. So like this, when you run it, then the next time you call the function, if you have f, x, and 1, which is there, it will ask of A and B. So if you say A is, let's say, 12, and then B is, let's say, 6. So it will simply just print the way it will simply come to the first one. So you have how many output? 3 to come here and then perform it, come and perform here, perform here. You could have continued this, print this up to the last part. It's the same thing we have here. This is another function. If I run this, you see that it's going to print so many things. So I think in a nutshell, so let's look at population. So this is, we are looking at the population of population estimate. That's the function name, and we are saying that, but we already know in our minds that this is how to calculate population. It's actually the current population, like if you want to estimate the population, times the rate of growth of that particular country divided by 100, all raised to the power n. All raised to the power n. The n is the number of years you want to estimate. So for instance, so what are the variables or the argument there? We have P, which is the current population, R, rate of growth, and N, the number of years you want to estimate. So we create the function and say that's our argument, P, R, N. We come to the function body and define how we want this argument to interact. So we follow this particular syntax that has been established. So it's 1 plus R divided by 100, all into bracket raised to the power N. And this is how we want it to interact. So when we run the whole thing like this, then the population estimate calculator is ready. Then the next time we are now asking, we call in population estimate. You can see the function is here. It will ask of the current population, rate of growth, and then N. In Ghana, our current population is 31 million. So is 31 million is 1, 2, 3, 4, 5, 6. Then it will ask for the rate of growth. Our rate of growth is around 2.8%. And then how many years do we want to estimate? Let's say in the next 7 years, what will be the population of Ghana? So I'll put there 7. And then when I do that, if I run that, it will tell me that the next 7 years, our population is likely to be 37.6 million people. And that's what it is. So maybe I could have gone ahead to take care of, death rate. And you know what that would have happened? I'll come here, and then now that I've estimated this PP, then I'll come and say the death rate is equal to the rate of death, and then we'll subtract that from this population, what estimate, and return that value, and that will give me the actual population by that particular year. But now, this way, that is for in the next 7 years. So what about if we wanted the population in, let's say, maybe some years back? This was in 2010. What was the population of Ghana? So it's the same thing. I will call the function population estimate. Then I will have our current population is 31 million. And then our rate of growth is 2.8. And then if we are looking for the last 10 years, or in 2010, that will be like 13 years, right? So because you are backdating, you use minus. So I'm going to say minus 13, and that's all. But when you run that, it tells you that in 2010, the Ghana population was around 21.6 million, and that's how it is. We can estimate forward, we can estimate backward. But here, I'm not looking at only rate of growth. I'm not looking at death rate. I have to incorporate that. So a simple R function to calculate area of a parameter of a rectangle. Yeah, I think by now we should be conversant with this. So the function name, rectangle, length, width. Area is length times width. Parameter is, but I think this is very important. We want to look at how to be able to write one function that can print different results at the same time. So I have the function name, which is rectangle. And so we have the function, which is length, and then the argument is length and then width. So we use our curly brackets, and we say area is length times breadth. That is finished. Perimeter is 2 times the length plus the width. You see, to execute this one first, and then multiply it by 2. And then we now have our results. The results will be equals to list. You use list. The list will be area, this particular area here is equal to area. Sorry, this area in text will be printed like that, equal to the area we have here. Perimeter will be printed like the way it is in text, and then equal to this perimeter we have here. And so that way we return results. Anytime we call the function, we are simply going to have more than one results coming out. So I'm going to run this, and then that is it. So now, if I come and I want to call in the the function, I simply, let me see if I can. So I have the function name is rectangle, which is here. And so let me try and run it and see. And so it will pack all the results into, it will calculate the area, calculate the parameter, and pack the results into what we call results list, which is seated here. So now if I highlight this, then it will simply print this for me. You see the area is 6, parameter is 10. This is a little bit, if you want only area, then I will now say results list. Then I'm saying that print only the results, but we are printing only the area. So we're not interested in the rest. It will print only area for me. If I want to print only parameter, it can do that. Here, we could have gone a bit to look for other, do a whole lot of different interactions of this argument, one and argument, length and breadth. And at the end, we can print a results list to all of them, and then it will be seated there. Each time we want, we can print whichever results that we want, and then we are good to go. And so, ladies and gentlemen, this is basically how we are able to build our own functions and then use it. We can always build the functions. The most important thing for you to know is that if you have a function name, let's say what you have a function name, and then that is almost like a variable followed by the word function, which is here. And then this open and close bracket is where you actually input your argument. If it is a function without argument, I've already explained that you don't have to put anything there. If there are some argument, then what argument? So you have argument, let's say 1, you can have argument 2, you can have, argument 3, then in that order. When you know that you are going to be having 3 arguments that will be interacting, then you now come here, you have your curly bracket like this, then come and do enter. So within this curly bracket, you can now do as much as you want, how you want this argument to interact, and that's going to. So you can now say, I want, let's say, argument 1. I want argument 1, okay, to be multiplied by argument 2, and then add argument. Okay. I think here it has to be, the syntax will have to follow this way and then that way. So I have my arguments. So here it will be RAG1, and then let's say I'm multiplying it by argument 2, and then I'm adding it by, let's say, argument 3. But maybe with this, I want to pack it into a variable. You see, it's always good that way. After you've done the interaction, you cannot come and say that retain the same interaction. So you pack into a variable. It makes the coding simple. So I can simply say, let's say the variable with AAG, and then I'm simply going to just do like this, so that after we have finished, then I can now enter here and come and say return. So what am I returning? Instead of returning the whole of this argument, this interaction here, I'll now rather return this. And then why we always pack it into a variable. It's not anything. So I'll now say AAB, and then I'm finished. So when you do like that and you run it, the function is ready. So each time you now call the function, it means you type the function name, it will ask for argument 1, 2, 3. So if I now say function underscore name, you see that it asks me of argument 1, 2, 3. So I have to now tell what is argument 1. Argument 1, let me say it is 2. Argument 2 is 6. Argument 3 is 7. When you do that, you run it, it will simply now come and look at how the arguments were interacted and print the results accordingly. So when you do that, it will print the results 19. And that's how it is. Practice this over and over, and then you become a champion of it. You can write this print matrix. You can write this to print whatsoever you want. You can add functions, inbuilt functions to it, and then you are good to go. I'm just unable to but I'll be having a part 2 of this, where I am going to look for a data set and how we apply function in analyzing that particular data set. And then this video has become too long. I wanted it to be short. So thanks very much for staying and sticking around. As usual, my name is Bigba Bright, and I love doing this. I have passion for doing this. If you love what I do, support me by subscribing to my YouTube channel and then following me, and also recommend others to follow. If you want us to work together, if you're also on, if you also like data science and stuff, and you want us to work together, link up and then we work together. Let's share knowledge and let's empower each other. Thank you very much, and I'll see you